Is everything working? Is everything working properly? Let's see. We have everything functioning ideally. Everything needs to function perfectly so that I can do my teaching. Okay. We'll go ahead and start. So, last time we left off right here. And the goal with this was to take, let's see, where's the sketch? Is to make an intake for this. So I'm gonna make an intake for this robot, and then that's about all we'll do with this robot. I'm gonna begin my review immediately after that of everything. So what I'm gonna do is make a part studio in context. Just select the origin. What that allows us to do is make a part studio, but it allows us to have this as a reference. So what I can do is create a sketch right here of exactly what I want, and I think I should be able to hide. This right here. Might have to do this each individually. So we'll just hide most of this. Hide that, and then hide the big one. Okay, more or less that's gone. Then we'll hide this. And we'll hide this. Okay, and then we'll hide that. And hide that. Okay. And we'll hide that gear as well. Okay. So here I've got, I don't want this. This can go away. Go ahead and hide that as well. I can kind of peer through that a little bit. What I could have done is just, well, actually I might be able to. Box select all that. No, I can't. However, what I can do is create a sketch on, I already have a sketch on this, so I can say, okay, I want a circle, maybe like a circle in the middle of this. I want like a slot for a 1/2 inch. Half inch. I want it to be 3 inches away from the front. Okay, and let's say I put like a beam or a bolt or a hex shaft. In fact, we'll go ahead and make a slot for a hex shaft right here. So, okay, that's our hex shaft, 1/2 inch hex shaft. And then I can design the rest of the intake kind of around this. And I could easily cut this out of plexiglass using a cutter, CNC machine, or anything like that. So I'm going to use splines for the rest of this, kind of freehand it. So let's say, okay, we want a hex shaft right here. The bumpers are going to come out here. So I'm going to look at this a bit. have it stick out a bit, up and out a bit. Move this down a tad bit. So we'll go ahead and make a construction geometry here. That's 9 inches. So, okay, the ball is going to be level with the ground, right? It's going to be right here. Level with the ground. So it'll come in, maybe like roll up against that. And I could easily, the point here is that you can easily iterate and change this. I can make this out of arcs and change it. I can make it out of whatever I want and change it, but we'll just leave that there for now. We'll just leave it as that. So we'll extrude this out. Extrude. We're on surface, we need to be on solid. We'll extrude these parts by a 1/4 inch. Actually, 1/5 of an inch. It's probably about how thick we'd make the intake. Actually, no, we'd do a 1/4 inch. So let's say, okay, that's our plexiglass. Now in the sketch, we can assign places for a hex shaft to be and go through. I could say, okay, I want my hex shaft to be a hex shaft right here. That would be 1/2 inch. Go ahead and copy this. Extrude these out. Also want to extrude that out. These will go, oh man, 9 inches, I think it was. Yeah, so we want ours to be a little bit wider than 9 inches. Let's see, this, the distance between this and this is 6 inches. 6 inches across here. And 25 inches. Yeah, 9. That leaves space for 9. Okay, we'll transform this now. So not quite ideal, but Z. Put it this way. Copy part. And then what we'll do here, this extrude, is we'll make this a new instead of an add. And this transform should be yep, there it goes. Yeah. Give me a second, internet's being a bit funny. Okay. So this is roughly what we'd want for our intake. So now I can say, okay, I want to insert there we go. So now I've inserted this and I'm like, oh man, that right there isn't quite lining up. That needs to be another. Needs to be another 3 3/4 inches. So the distance between this and this needs to be 13 inches. So now I can say, so 13-inch hex shaft. Now this extrusion can be 13 minus 1/4 because of the plexiglass here. In reality, the hex shaft would extrude beyond that point. And then make this transform 13 inches. One. Okay, so it needs to be 1/4 inch less. Okay. So now I could insert my ball here from, ooh, I don't know if it's in here, game pieces. Yeah, I don't know if last year's game pieces are in here, CAD. The cool part about that is we could insert a part studio, just put a background noise. And I could make a semicircle right here. 9-inch. Cut it in half. But now I've got my bowl. This is the 2019 bowl. Insert. I can say okay. We'll align that to the ground. Okay. This intake right here. Fit in here. Okay, it'll fit in there. Now this could easily fit through there, so we might want to put another hex shaft there. Fits through here with compression, so we'll want compression wheels on this. Maybe move this hex shaft up a bit. And then we'll need some sort of mechanism to prevent it from here. Say, okay, the rest of the robot can be designed. Anybody has any questions, go ahead and ask them. I think we'll move on from this. Go ahead and this last week will probably be the final week that I do classes. This might probably be the final day that I'll do classes. I'll go ahead and review everything that we've gone over thus far, start to finish. Just go ahead and hit every feature, talk about it. Make a new document. Okay, so, okay, sketching, Shift S to sketch, R for rectangle, C for circle, and L for line. Tools are up here. You can either do center point rectangle, aligned rectangle, R for center point rectangle, G for corner rectangle. C for circle, you have ellipses and 3-point arcs. Ellipses can make ovals and things like that. You have your arcs here. So I can say, okay, I want this to be A for arc. I want this to be rounded right here. When you have a tool that you're using and you see a yellow circle or a yellow square, kind of like this, pop up, that means that you're selecting the center of that. So if I go mouse over the center of the line, yellow square. If I have a dotted line that shows up, that means I'm aligned to that object. So you can see there's a dotted line aligning me to the vertical of the origin. Or let's say like dotted line aligning me. If I mouse over this and then move, it'll align me to that. Mouse over this and then move it here, it'll align me to that. Over that center point, it'll align me to that. If I align myself to, let's say, the center point of that, it'll now align me to that. That's what the dotted line does. Grab polygon, this is for hex shafts. Click, click. Choose how many things you have. Then you can set the dimension with D. A whole inch hex shaft. This isn't defined. Blue means it's not defined. Black means it is defined. This is blue. Let me say, okay, I defined this. Why can't I move this? Or why is this blue? I defined it. I didn't actually define it. I defined the distance between these two lines. So these two lines, definition, these are going to stay here. However, this right here, this I can move around. If I were to define the other side and say, okay, I want this to be 3 inches. Now, this is defined. I can't move it around. Lines, okay. Alright, dimensioning. If I select 2 lines, I can select the angle of that. So I can say this is a 40-degree angle or a 120-degree angle. Hold on. Double click the definition to change it. 120-degree angle. The distance between something. Say this is 2 inches. Also, select the distance between 2 points. I can say this point and this point going to be 2 inches apart. But also say, let me just test this real quick. I also select the distance between them in a radial zone if I keep it level. So say this is 2 inches. I can say the dimension between this and the origin is going to be 2 inches. Now, this will rotate around that by 2 inches. Your point tool is right here. Your spline tool is right here. Splines are simple. They're for freeform stuff, more or less. You can edit these to be calculated, but I haven't yet used them for anything calculated. When you're creating a spline, double click to complete the spline, then you create another one by clicking again. Double click, stops it. If you're starting a spline and you hit escape, it'll cancel the last thing that you're doing as long as you haven't clicked. You've got text. Use is for if I have some 3-dimensional object in the background, like if I had that, I created a rectangle right here. Put it up. Go back to the sketch. By feature. The sketch, and I use this rectangle. It'll project that geometry onto my, what do you call it? Sketch that I'm currently using. So this is useful for designing around different parts in your model. You've got construction geometry, which means when if I grab that and hit Q, this will now not affect anything. It basically doesn't exist. It's just there for reference. It's more or less a dimension line. Sketch fillet is for filleting before you sketch, or before you extrude. Space, that fillets that. Filleting is just another fancy term for smoothing. So I can set that radius real high. Offset is just exactly what it sounds like. I can either offset or I can inset, depending on which way I drag this arrow to face. Linear pattern will create a linear pattern. If I select this, let's see, I'll go over here to the front plane. I will create a rectangle right here. I want to linear pattern this rectangle. You don't want to click off of it, it'll complete it. Linear pattern that. So it's saying this is spaced an inch apart. We're going to make it spaced 5 inches apart. So now we're going to make it spaced 2 inches apart. That means it's 2 inches apart and there's 3 of them. So that means I want to make them 2. I want the other way to go that way. I want these to be 2 inches apart. I want it to go the other way, so I want them to be negative 2 inches apart. I want them to be 3. That's what those tools do. This saves a lot of time. Circular pattern is same thing, but it does it around an origin. Move this square to change where it does the center point around. This changes the angle of each item. And then right here, we'll change how many of there are. Then you've got transform. This just allows you to grab something and move it. Dimension, these are constraints. You've got vertical, horizontal, perpendicular, equal, midpoint, parallel, concentric, tangent, and coincident. These all do different things. Fix is a good one. It allows you to grab and just make something standard. All right, there's our sketch stuff reviewed. We're good there. Okay, revolve here. You've got extrude, which is pretty simple. When you have geometry, extrude will extrude it. That's Shift E. Revolve will, first I make a line. I make some geometry along that line. Revolve will allow me to take this, revolve it around that line, and then it will make a 3D model by swinging that around like that. This sweep, it'll allow me to make a line. And this can be a complicated 3D line or whatever, doesn't matter. And I can make a circle connecting to that line, or whatever object I want. I can then sweep it. I want to sweep this along this. Now that's a little too bent for it, but that's good for making pipes and things like that. Loft is for, let's say I wanted to make like, I don't know, tip of a vacuum. Easily create a square here. And then we'll go ahead and review the plane tool. Plane allows me to make a plane. I can make a mid plane between 2 other planes or 2 points. I can make a point normal, 3 points, which allows me to select 3 points and it'll create a plane that's aligned to each of them. You know, different things. Right now we're just going to do offset 1 inch, and then we'll do it again. Another plane. Offset. Create a circle in the middle of that. Good. And create a sketch on the top, circle in the middle of that. Good. P is to show and hide planes. We're going to hide all the planes, and then we're going to loft this, this, this. As you can see, connects all of them with 3D geometry. Pretty useful for making odd shapes to pick up certain weird shaped objects. I'll go ahead and show my planes by hitting P. Rectangle. Extrude. So we've got fillet. You've got Shift F. It allows you to smooth something out. You can select lines, planes, points, whatever. Chamfer is the same thing, but it just cuts it horizontally or diagonally. You can set 2 distances. You can set equal distance. You can set distance and angle. So each of them are useful for different things. You've got rib. I won't go over that. Shell. Just Does what it sounds like. And it just shells the inside of that. Hole is just, you select a circle and it'll make a hole. It's like Hole Wizard from SolidWorks. External thread, it'll externally thread something. Then you've got your linear, circular, curve patterns. You've got your mirror, Boolean, which will add two objects, subtract. So if I got like a pin right here, and then like I'll just show you an example. I've got like a big cylinder right here. That's a separate object. Cool. Boolean will allow me to add those together. Now this is all one bit of geometry. You've got transform, which rotates, moves things. You've got split, which allows you to cut an object along a plane or another object. Cut this in half. Then you've got replace face. You've got your plane tools. We won't go over those. Helixes, just makes a helix. 3D fit splines are pretty nice. You just select some vertices. And it will make a spline that goes between them all. Got curves, different weird stuff. Mate connectors can be placed onto things to act as reference geometry or to transform something along it. Sheet metal. Okay, we'll cover sheet metal in a separate episode. Okay, now we'll do assemblies. Okay. Fasten will connect two mate connectors together. Mate connectors can be found on Fasten will connect two things together on the mate connectors. Mate connectors are automatically generated on each face of an object. Revolute mate will allow two things to rotate on the same mate connector. Slider mate will allow two things to slide along the same mate connector. Planar mate, I think, will align things along the same plane. Cylindrical mate is basically the revolute mate and the slider mate combined. Pin slot mate will align things along a slot, same geometry in the middle. Ball mate will allow two objects to rotate in all directions on the same thing. Good for making anatomy, ball and socket joints. So if I say like, this is a ball and socket joint. It's really good for 3D printed joints because they're very easy to 3D print and they must always work first time. So I could put this, snap that in there, and then allow that to rotate in all this direction. Think of it like your shoulder. You can move your shoulder in all directions. You've got your parallel mate, your tangent, and then you've got things like here, snap mode. Snap mode allows you to just like drag things, snap it easily. Something else. Place instance, assembly linear pattern, assembly circular pattern. Gear relation for things with teeth or belts or things like that. And then we went over create parse studio and context. Okay, I think we reviewed everything. I'm going to go ahead and send everybody out. Now that we have this review, I'm going to be publishing videos later that recap the whole lessons. That's going to be the end of this CAD class. If we have any questions, go ahead and ask them. Otherwise, I'm going to let everybody go. Any questions? I think we hit everything. Sketching, modeling. We'll go ahead and go over feature scripts real quick. Feature scripts, you can find them online. They each do different things. Something will make entire beams for you. Some will thread object automatically. Almost all of them are really useful and save you, dozens of minutes of time. Some of them can save even hours of time modeling. I know that I've certain ones like Beam Creator or Thread Wizard has saved me easily hours of time modeling. Did I go over Lighten? Will cut holes into things so that it will lighten an object. Basically, if you've got like a piece of sheet metal that doesn't need to be a flat piece of sheet metal, it'll cut holes in it so that it's lighter. That's a pretty useful tool. I think that's about it. you don't know what MKCAD is, it's in the App Store. It has every FRC part. There's version histories over here. You can make versions and see every change that you've done. You can roll back up to like 50 changes. If you have the enterprise version of Onshape, you can roll back even more. You can insert images and then go into a plane or a sketch and then insert the image as a plane. Anything else? You got different views here. You got your measuring tool here. You can select a couple of objects and take the average of them or take the distance between them. I think that we've gone over everything. So yeah, I think we're good. All right, I'll let everybody go. Go ahead and end this out. This will be the shortest video that we have because it's a recap video. Thank everybody for attending. This is the last day of CAD classes, but I will be posting videos with kind of shorter, more boiled down videos that don't have any idle time. It's just throwing knowledge at you really quickly. See everybody. Have a good day.